Section 6, Video 2. We're going to do these two examples first because they are similar in nature. Again, we're solving by elimination, which we say we will add vertically, and in doing so we want variables to cancel. So if we look at this system, we notice that we do have opposites. And that means that we can use elimination right from the beginning without having to do any modifications to our system. So if we add vertically, negative 5r plus 5r cancel out. Positive 4s plus 13s gives us 17s equals 34. Divide by 17, and s is equal to 2. I don't have x and y variables, but again, if we graph these two lines, again we are looking for a coordinate. So we need two values. Now typically if we don't have x's and y's, they are ordered, so it's alphabetical. So r would be put first, s would be put second, and that's what we know so far. So just like substitution, we take that value and we can plug it into either one. The negative to elimination is that one of the equations isn't solved for a variable, so this part isn't as quick. So let's just use the very first one, and I plug that in and I get negative 5r plus 4, and s is 2, equals 5. So negative 5r plus 8 equals 5. Subtract 8, and negative 5r equals a negative 3. Divide by negative 5, and r is equal to 3/5. So here's an example where we have a fractional answer, but again it's exact. If we graphed it, it wouldn't be that accurate. Alright, our next example is our third one, and again we're looking for opposites here. There are no opposites. However, I have the ability to change equations by multiplying the whole equation by a number that would make opposites be created. So again, we want to be efficient here. I can multiply the second equation by a 6 to make the 30 to match up with the 30 above it, but I would have to multiply by a negative 6 in order to get them to be opposites. So again, I consider that two things. Multiply by 6 with the negative, and now I'll be okay. But if I look at the y's, I notice they're already opposites. So in prepping it, there's really one less thing I have to worry about. So here, I would just have to multiply the equation by a positive 4, and I would get opposites, which is my goal. So again, it's okay if I multiply the whole equation by 4, it's still equivalent, but remember, I have to multiply the whole equation by 4, which would give us 20x minus 20y equals negative 20. Now that's the new equation. So this one is now replaced. So if I add vertically, I have 50x, I'm using this equation and this equation now, 50x these are gone, and we get negative 100. Divide by 50, and x equals a negative 2. So again, we're looking for a coordinate, and we just found our x. So I can take that value, plug into either of these equations. I can actually even plug it into this one if I want, but again, arbitrarily, I'm just going to plug it into the first one. They both look interesting to me in terms of plugging it in. They're both long and with big numbers, so just plugging in the number, and I get negative 60 plus 20y equals negative 80. Add 60 to both sides, and we get 20y equals negative 20. Divide by 20, and y equals negative 1. So that is our y value of the coordinate where they would intersect. And this ends section 6, video 2.